All right, here we're going to look at 5.3b. There's some more examples of multiplying matrices. So one thing I like to do when it comes to dealing with matrices is I like to test things. I like to see does this work? And so part of that is I want to see if matrices act like numbers. So what I mean by that is, um, you know, in arithmetic, right? We know that things like 7 plus 4 is the same thing as 4 plus 7, right? We also know that 5 times 2 is going to give me the same result as 2 times 5, right? So one thing I want to take a look at is let's see if we multiply a couple of matrices, would I be able to turn them around and would they still be equal? All right, so let's investigate that here. Let's take a look, and we're going to take a first matrix and we're going to multiply these here. So I'm going to take 3, 1, 5, negative 2. All right, I'm going to multiply that with 6, negative 2, 1, and 0. Now let's just do a quick check to make sure that I can even do this. Here I have a 2 by 2, right? 2 rows, 2 columns. Multiplying that with another 2 by 2. All right, these guys match, and the resulting matrix is going to be a 2 by 2. All right, so these guys match. The result is going to be a 2 by 2. So I get 1 row and row 1, row 2, column 1, column 2, right? So row 1, column 1 is this position. So I'm dealing with row 1, column 1. Row the first, column of the second. So 3 times 6 gives us 18 plus 1 times 1 is 1. So notice I'm skipping a step from the last video where I actually wrote down all the multiplication. And that's just in an effort to go as quickly as possible through this. So if you really need help with all that, that's fine. Write that extra step in there. I'm not going to say no to it. Maybe even pause this video, multiply these two. So pause it now, multiply these two out, and see what you get, then hit play to see if you got the same. All right, so here we're at row 1, column 2. So row 1, column 2. So 3 times negative 2 to get negative 6. 1 times 0 to get 0. Here we're at row 2, column 1. So no longer looking at this. Now we're at row 2, column 1. So 5 times 6 is 30. Negative 2 times 1 is negative 2. So I'm done here. So row 2, column 2, row 2, column 2, 5 times negative 2 is negative 10. Negative 2 times 0 is 0. 0. Okay? Now I can clean this thing up. My 2 by 2 resulting matrix is going to be 19, negative 6, 28, negative 10. Now I'm going to test this thing. 5 times 2 we know to be 10. 2 times 5 is still 10. All right, I was able to switch them around and got the same result. Can I do that with matrices? Well, let's take a look. Let's switch this bad boy around and see what we get. So 6, negative 2, 1, 0 times 3, 1, 5, negative 2. Multiply it out. We already know the resulting matrix is going to be a 2 by 2. All right, go ahead and pause now. Go through the process. Find out what this resulting matrix is, and then hit play to see if you're right. Here we go. Row 1, column 1. So 6 times 3 is 18. Negative 2 times 5 is negative 10. Row 1, column 2. So I get 6 plus 4. Right? 6 times 1 is 6. Negative 2 is 4. Row 2, column 1, row 2, column 1. 1 times 3 is 3. 5 times 0 is 0. And row 2, column 2. Row 2, column 2. 1 times 1 is 1. 0 times negative 2 is 0. So my resulting matrix then I get is 18 minus 10 is 8. 6 plus 4 is 10. 3 and 1. Whoa, buddy. Whoa. These are not the same. These are not the same at all. So that is very interesting. So we can make this grand statement now. Matrix multiplication does not commute. Highly suggest you watch the Khan Academy video for extra practice on multiplying matrices.